And so it's time for another video on using Microsoft Excel for our statistical analysis. Now I hope you've watched the previous videos in the series, especially the first one, because I go over some of the steps quite rapidly. Now in this video we're going to examine a binary categorical variable, a variable that has two classes or two levels of outcome. We're going to choose one of them as a success and look at the proportion of those successes. We're going to use a one sample z-test, also looking at the confidence interval for that statistic. I'm also going to take a look at the chi-square goodness of fit test. So we're going to look at their proportions using an x squared statistic. Our example data is going to be fairly contrived. We're going to imagine that there are two parties and that we're going to go out and vote for those two parties. So before the voting takes place, we select a sample of individuals from the population that are going to vote, and we're going to count the proportion of how many in that sample voted for one party versus the other. Now I'm going to use generic party names like orange and purple, which has no bearing on reality whatsoever. Now we are going to have a null hypothesis, and that null hypothesis is going to come from perhaps just averaging over what previous elections looked like. But we are going to compare the proportion that we find for our sample against that null hypothesis. So we can see our data here. We've got two columns, an ID column, just a number, sequential number for all the subjects in our study. And our variable of interest is called vote. And we're just suggesting here that there are two political parties that you can vote for. My apologies if your party is called purple or orange, but those are the two parties. And we can see subject number 1 selected purple, subject number 2 orange, 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 purple, etc. And we are going to look at the proportion of people who chose purple and who chose orange. Now this is a sample taken from a population. And so what we're trying to achieve is to look at what would the population proportion look like when it comes to voting day compared to this sample that we've taken from the population. As always, we're going to make a copy of our data. So I'm holding down Shift, right arrow, still holding down Shift, hitting Control or Command, down arrow, and all the way down. So we see we had a sample here of 226 subjects. I'm going to hold down Command or Control, and I'm going to hit the C key to copy. I see my marching ants. I'm going to go down, create a new sheet, and I'm here in cell A1, and I'm going to hit paste values, and I've got a copy of that. I'm going to come down and I'm going to rename the sheet copy. And of course, as per usual, I will change this into a table, but for now, let's make a new sheet. And in this sheet, we're going to do a z-test for proportion. So I'm going to call my new sheet z-test, and I'm going to make another copy of my data. And so paste values. I've got a copy of the data. I'm going to go to the insert tab, and I'm going to hit the table button, the third one across. I've got checked here. My table has headers because indeed in the first row, I have the names of my columns, ID and vote. And now we have a table. Now we are talking about proportions. What proportion of all my subjects chose orange and what proportion chose purple. Now I've got to have one of those be my success class. So it is a binomial variable. It's categorical with two levels. So we're going to call it binomial or dichotomous or binary, two possible outcomes. Now one of them I'm going to choose as my success, and the other one then becomes the failure. Now that has nothing to do with the actual meaning of the English words success and failure. It's just the one that we choose when we do have a binary variable. So what I'm going to do now is I'm going to insert a pivot table. So here I'm just in any of the cells in my new table. So I'm going to go to insert, and then the first button is pivot table. The table is already selected for me. We can see there table number 1. I don't have to change anything there, but I'm going to go to existing sheet, and I'm going to click on my little selector button, and maybe I'll put this in cell E. Let's put it in E1. And I'm going to click OK. And on the right hand side at the top, I see my two columns, ID and vote. Vote is obviously the one that I'm interested in. So I'm going to take it, hold down my mouse button, drag it all the way down to the rows. And I'm going to take it again and drag it to values. And by default, it is the counts. And that's exactly what we're interested in. And we see of our sample here, 131 people chose orange and 95 chose purple. And so let's suggest, just for the sake of argument, that I'm going to choose orange as my success class. And what we might want to do is to compare to some previously known proportion of people who chose orange. So maybe over the last couple of election cycles, it turned out that orange got 51% of the votes. So I'm going to call that my null hypothesis. or the value at least, the proportion under the null hypothesis. And I'm going to say, let's assume previously that they received 51% of the vote. So that's all I'm going to put there, 0.51. I'm just making a note of it. Now let's see from our sample what the proportion is. So I'm going to call that sample proportion. I'm just going to go between the E and the F at the top, those column names, and I'm just going to double click and that'll expand so that I can see everything that's typed in all the cells in that column E. And so how do I work out what the sample proportion was? Well, that's very easy. I'm going to say equal, and that's the number of people who chose orange. Remember, that is my chosen success class, divided by, so that's forward slash, and then I'm going to click on the 226, the grand total. And we see here that it was about 0.57964, so about 58% of the sample selected orange. Now, is that significantly different from the 51% under my null hypothesis? And I said in this instance, the null hypothesis just came from the fact that maybe that was some average over the last couple of election cycles. So let's look at what the difference is. Let's type in difference in this cell. Now you can put this anywhere, you can use different words, but let's look at the difference. That is going to be the difference between what I found, that's my sample proportion, minus what we expected under the null hypothesis. So just minus, and then I'm clicking on the 0.51. And I see that is the difference. The sample minus the proportion under the null hypothesis. Now we also need a standard error. And I'll put the equation on the screen as you can see here. And so what we want is we want the square root. So I'm going to type in equals SQRT. There's square root. I'll click on that. I'm going to put 2 parentheses because what I want is this observed hypothesis value 0.51. multiplied by the failure proportion. So that'll be 1 minus, then clicking on the 0.51 again, close that set of parentheses, another set of closing parentheses, and then forward slash to divide by the total number of people in my study. I'm clicking on the 226 there. I'm going to close my final set of parentheses and hit return. And there we see our standard error. Now we can just work out our z-statistic. And that's simply going to be the difference. So I'm saying equal the difference divided by the standard error. And there we see our z-statistic, 2.09. And we already know from having looked at so many of these examples is the fact that for a z distribution, a standard normal distribution, if I chose an alpha value of 0.05 and I have a two-tailed alternative hypothesis, that my critical value is going to be at negative 1.96 and positive 1.96. So let's put down an alpha value, a critical value, and then also a p-value. So let's select a alpha value of 0.05. So we want a 5% level of significance. What would the critical value be when it comes to an alpha value of 0.05? Now remember, we're doing a two-tailed alternative hypothesis. So in this instance, we're going to say that the sample proportion of successes is not equal to 0.51. Under the null hypothesis, we say that the proportion of our population, that's always a population proportion, of the success class, which is voting for orange, would be 0.51. And under the alternative hypothesis, it's not 0.51. That is a two-tailed alternative hypothesis. So when it comes to a critical value, there'll be a positive 1.96 and a negative 1.96. Here though, let's just concentrate on the positive one. So I'm going to say equals norm.inv. There we go. And now it says it needs a probability. Now, I want the upper tail, so that's going to be 1 minus the 0.05 divided by 2. So that will be actually 0.975, comma, standard normal distribution, so the mean is 0, and the variance or the standard deviation is 1. And so we see the positive critical value there, 1.96. We are 1.96 standard errors away from 0 from the mean. And that was because we're using an alpha value of 0.05 and a two-tailed alternative hypothesis. And of course there, our z-statistic is more than that critical value. And we would reject the null hypothesis. We would say that in the population, the proportion of people voting for orange is not 51%. We could indeed say it is higher, it's at 58%. Let's work out a p-value for this. So I'm going to say equal norm, and now I'm going to go to norm dist. It wants x, that's actually my z-statistic. So I'm going to click on the 2.09, comma, the mean is at 0, the standard deviation is at 1, and then comma, I want cumulative. So I'm going to hit on the true button and I'm going to close those parentheses. I'm going to hit enter now, but I'm actually not done because what we can see there is 0.98. Now that 0.98 is going from the lower tail from negative infinity up until that point, up until 2.09, which is over on the right tail. So let's go back there, and what I will do is just click right after the equal symbol and say 1 minus. And I'm not done yet, so let's enter that, and we see it's 0.018. The last thing that I want to do, because remember now I'm only doing the small proportion in the upper tail, I have to multiply this value by 2. I want a two-tailed alternative hypothesis. So let's click in there again. And what I'm going to do right after the equal symbol again, I'm going to say 2 times, and I'm going to open my set of parentheses and I'll go right to the end. And what I'll actually do is do it right up here in the equation bar, close my set of parentheses, and now you can see the complete formula there. And now we see the p-value. The probability of having found the sample proportion of 0.58 or more extreme, and I'm also doing it on both sides of my z distribution. And we see the probability of that was only 3.6%. Again, that is less than my alpha value of 0.05, showing me by a different decision that I reject the null hypothesis. Now, another great thing about my z-test for proportion, my one sample z-test for proportion, is that I can work out confidence intervals. So let's stick to a 95% confidence interval, which means that my confidence coefficient C is going to be exactly what we have here, the critical value. So there's no problem there. Now I have to work out my margin of error. And again, I'll put the equation on the screen here, and let's put margin of error. And that's going to be equal to, so I'm putting equal, that is C, our confidence coefficient, which is right there. It's the same as the critical value, times, now I'm going to put SQRT for square root, open parentheses, open another set of parentheses. Now it is the sample proportion. When we worked out the Z statistic, we were talking about the population proportion. Now I want the sample proportion times, and I'm going to open parentheses again, 1 minus the sample proportion for orange. Close my parentheses, close it again, divided by the sample size, which was 2 to 6, way up there. Close my parentheses, and that's my margin of error, about 6.4%, which means we can think of the lower bound. Let's put the lower bound there, and let's put the upper bound. So for the lower bound, I'm going to take my sample proportion and I subtract from that my margin of error. And for my upper bound equals my sample proportion plus my margin of error. Now what I might want to do is just to do a bit of rounding. So I'm going to go down here, column F, and let's do this sample proportion. I'm going to say equal round. And then I'm going to click on my 0.579, comma, let's do 2 decimal places. And I'm going to do the same for my margin of error. So equals round. I'm going to click on the 0.06, comma 2. And because this is relative cell referencing, meaning if I'm in this cell, which is H24 at the moment, with my formula, I'm referencing the value that are 2 cells to the left. I can simply go right there. If I hover over the right bottom, you see my cursor change. I'm just going to hold and drag down, and that'll do the rounding on 0.515 and 0.64. So we see the rounding there. And so let's write a conclusion here. Let's think about a conclusion. We are saying that, remember, we chose orange as our success. It's just a choice. It does not mean that choosing the orange party was the success over the purple party. That's just the one that we chose. So we say in our sample, 58% of people, which we can see there, chose the orange party. And that is significantly different from the 51% under the null hypothesis. We see that by the p-value approach. Our p-value was less than 0.05, and we saw our z-statistic was outside of our margins, outside of the critical values. And so we rejected the null hypothesis. We can then say, in fact, we think, because now we're predicting the future, this is usually what happens, take a sample from the population, predict what the outcome is going to be of the general voting outcome, the population value. we'll say we think it's going to be more. It's going to be 58% for orange. And now we can say with a margin of error of 6%. And you have heard this on the news before, saying that we're projecting a 58% vote for orange with a margin of error of 6%. So we are thinking that the voting for this orange party is going to be between 0.52 or 52% and 64%. 52% and 64%. And look at that, our null hypothesis value is not within these margins. So once again, that supports our rejection of the null hypothesis. So that was the one sample z-test for proportions, but we can also do a chi-square goodness of fit test or a chi-square test for proportions. Let's have a look at that one. I'm going to open a brand new tab at the bottom, a brand new sheet. And this one I'll call just chi-squared. So let's have a look at that. I'm going to go to my data again. I'm going to copy all of it, come to my chi-square, and I'm going to paste the values. And I'm going to change this into a table. And there we go, it is a table. And once again, right up here, I'm going to insert a pivot table. So insert pivot table. Let's select the range. I'm going to select this whole table. There we go, and I want everything in an existing sheet. I want this pivot table to be an existing sheet. I'm going to choose E1 again, open up, select OK. Once again, I'm going to take vote and drag it down to rows. I'm going to take vote and drag it down to values, and as the count, as we had before. Now let's do a couple of things. I'm going to say observed and expected. Now let's also just put here under the null hypothesis, we suggested that 0.51% of people selected our orange, which was our success class. Now let's have a look at what we observed. Let's put orange right there and purple right here. So what did we observe for orange? Well, it's right there, was 131 people. Let's look at purple. Well, it was 95% of purple. Chose purple in our sample. But what would we expect if the null hypothesis was true? Out of 226 people, we thought 51% would choose orange. And so let's just work out that proportion. So that's going to equal the 226 multiplied by the 0.51. So if you took 226 people and the null hypothesis was true, you would expect 115.26 people. So let's look at purple. Now that is just going to equal the 226 minus the 115.26. You could also have said 226 times 0.49 or 1 minus 0.51, and that's where we have. If the null hypothesis were true, that 51% of people chose orange, if I then take 226 people, 51% of that would be 115.26, 49% of that would be 110.74. That is what I would have expected. Now, once again, I'll put the formula on the screen, and you can see we can work out our x squared statistic. So let's put x squared. And our x squared statistic says, let's do the following. That is going to equal, and I'm going to say observed. So I put a parenthesis. So observed minus expected. Close my parentheses. And then I'm going to hit Shift 6 so that I can put a 2 for squared. So I'm saying observed minus expected squared divided by expected. So let's do the same for purple. That's going to equal, open parentheses, observed minus expected, close parentheses, Shift 6, 2 divided by expected. And there I get the result 223. And if I just sum over these, I'm going to say equal sum. And then I'm just going to drag over these two values. So I'm summing over those two, close, and there's my x squared value, 4.386. That is my x squared statistic. Now I have to think, what is my degrees of freedom? My degrees of freedom, let's put degrees of freedom. That is going to be, this was a binary variable, so there were two possible outcomes, and then I'm going to subtract 1 from that. So let's say equals 2 minus 1. That's very simple. That's just 1. So this is going to be a chi-square statistic on 1 degree of freedom. Let's think about an alpha value. So in our instance, let's choose 0.05. And now let's think of the critical value. So for the critical value, I'm going to say equal chi. And we see there chi-sq.inv is the one that I want. The probability that I'm after is 1 minus my alpha value, and comma, my degrees of freedom is right there. It's 1, close my parentheses, and there I get my critical value, 3.84. And my chi-squared statistic, or my x-squared statistic, I should say, was 4.386666794, and that is bigger than my critical value. So once again, as with the z-test for proportions, I am rejecting the null hypothesis, that the proportion of people in the population that will choose orange is not 0.51. Indeed, from our little sample, we think it's going to be 0.58. Can we also work out a p-value? Indeed we can. So that's going to equal 1 minus the chi-square dist. You can see there, chi-sq.dist. And it wants my x-squared statistic. There we go. Comma, my degrees of freedom, which is 1, comma, cumulative. Yes, that is true. Close my parentheses, and we see, look at that p-value. Does that look familiar? 0.036. It is smaller than my alpha value of 0.05, so I reject the null hypothesis. We are saying that from our study, we don't think that the population proportion of people who are going to choose orange in the upcoming election is not 51%. In actual fact, our study shows it's going to be more. It's going to be about 58%. And so this is one way to use Microsoft Excel to look at a binary variable and to look at the proportions of our success class. We used a one sample z-test for proportions, but we can also use a chi-squared goodness of fit test or a chi-squared test for proportions.